Oh, that's actually a semi over.
Buttons do 4 things. Each one. Alright, so Brittain and I are going to try something new today. I've got a few things to my kit here. Ordered a bunch of stuff. I got some little jumper things. I've got all this off Amazon, and you can get a link to my Amazon referral URL from the promotions page, thejohnnyoshow.com/promotions. So if you want to buy anything from Amazon and you want to buy through my link, I would greatly appreciate that. But I bought these little kits on Amazon. This has got a bunch of just LEDs. I already had some resistors and capacitors and stuff, but this came with it too. This has also got a USB and power jack thing that you can put on a breadboard, so that's pretty handy. Some ribbon stuff here. So that's just something else we got. This is something I picked up a while back from Radio Shack, and it's all falling out. This was it's basically more of what I just showed you, but an older one. It's got some breadboard stuff in it. And then I bought these. It was like $4. And it was like 12 of the little mini breadboards in it. And I got me a box of capacitors, all different kinds, and a box of resistors, all different kinds. And I've also bought me a bunch of 555 chips. So we're going to do some experimenting today with the 555 chip and different kinds of timers. I have these LED lights that kick on by motion, but they only stay on for 1 minute and then turn off if they don't detect your motion. It's a longer period of time, it's more reasonable. And we're going to see if we can build our own circuit. We're going to test it first using breadboard and stuff and see if we can build our own circuit to resolve that issue. So, plus I figured it'd be a good way to start in learning this kind of stuff. The way these breadboards work, you just put your wires in these little pins here, these little holes, and you can use that to make jumper positions to create your circuit board. So we're gonna experiment with that. So first thing we're gonna do is we need a way to get power to it. So I'm gonna look at this little guy here and see if I can plug this right to a board, or if I have to use jumpers. Looks like these will line right up. Look at that. So you can take this little guy here, and we are going to connect it right to the board on these pins. If I could see, it would help. Awesome. So there's our first step. Now we need the 555 chip, and we've never done this before, so we're learning this right at the same time. I got a page pulled up there, Britty, so we can just put this on the board. That's probably as good of a starting point as anything. We've got a way to power, and we have our chip. Now we got to figure out how to make that chip flash an LED. So let's go ahead and grab an LED out of something here. Here we go. What color you want, Britty? Green?
Blue.
Blue? You want blue? So what we could do is could actually test that without the timer. We could go ahead and experiment with just getting the LED. So what we're going to do is we're going to find out what an LED needs. How to power an LED. And so I'm going to Google that real quick, and it's probably going to tell us we need to have a resistor. So therefore, here we go. Go ahead and read this little area here. Means I can't see it right now.
Powering an LED is not as easy as simply hooking it up to a battery. An LED has almost no internal resistance. Therefore, if you hook it up directly to a battery, it will burn out quickly as the current flows unimpeded through the LED. Let's add a resistor to the LED circuit. This tutorial explains how to calculate the resistance needed. In order to calculate the resistance needed, Ohm's law is used. For example, suppose you have a 12-volt supply, a white LED with a forward voltage of 3.4 and a current of 20 milliamps. First, calculate the voltage by subtracting 3.4 from 12, giving 8.6. Now calculate the following. R equals 8.6 divided by 0.020 or 430 ohms.
So this little kit we bought on Amazon, it's the upgraded electronics fun kit by Elgoo. Elgoo? Is that what it says? Elgoo?
Sure, let me look at the URL. Elgoo. Anyway, you go to the URL and it'll give you all the details about the /2.
But to just show you what it says here, it shows all the components, but it doesn't really tell you what they're rated for. So it says go here to get that information. So I just collect old wall warts. I had an old Netgear 12-volt one, and it has a little. This is cool because it has a little green power LED letting you know that that's working. We don't have anything really happening over here yet. So this is connected to there. Ground is connected to there. This is positive connected to the resistor. Here goes nothing. Okay, it could be backwards. Remember, lightning diodes have a polarity. Let's turn that back off. I got it all in the right spots. Well, I don't care about that. Here goes nothing. There we go. We did it. We have a light. Yay. That's all we've done. But we have a light. Does that make sense? Mm-hmm. Okay. And you understand why you have to have a resistor, right? It's too much power. Basically, the resistor reduces how much this is getting. All right?
Yeah, I got it.
All right. So now we have our resistor, which it gets from the power, and now the power has to go to back to the chip. So I moved it back to the leg for the chip.
Okay.
And then we need to have a.
No, we need something that connects the power to the resistor still, don't we? Because it's not connected to it, is it?
Right. So we're going to have. There's on the chip. One of the legs is the trigger, which is like what tells it to start, and then power comes off that chip, and eventually it'll disappear. So it'll let the LED for a time, then it turns it off.
Okay.
So now we have to go back to our 555 instructions here.
Yeah, I don't know where those are.
You don't know where those are? Okay. So.
Where those at?
All right. So I just realized we just learned something. We were originally using jumpers from here and connecting accordingly. But the whole point of these whole sides here is, and the reason why they actually line up perfectly with this board, I put this board here, I put it to the pin configuration for 5 volts because I want to use 5 volts going down here. And so this side is going to be negative and that side is going to be positive. So basically I've now moved my LED, I've got my ground for my LED basically connected to the ground row of the breadboard here. And so that's how that works. So we're gonna go ahead and try to get all this wired up and then come back to you. So we got it right. We got, you can see everything we got here. We'll try to figure out this a little later. But basically we've got our resistor and our main capacitor here for controlling the delay. I've got a 750K, we used a 750K resistor, so it gives us a few seconds of light when we hit the button. So now what we're going to do is we want to have this go for about 15 minutes is what we want to do. So that's what we're looking to do. It's that guy. Okay, so it says, it's kind of a little scary. Okay, so we are taking out our 22 microfarad capacitor, which is this one right here.
I got an 820.
You have an 820?
Mm-hmm.
All right.
Okay.
Okay.
Actually, I have a 910K.
Let's go with 820. That's close enough. So here's my 750. Give me an 820.
Okay, just a second.
And I'm going to take out the 22, and I'm going to put in the negative. It goes here. That's scary big. That's really, really big. I hope we don't blow something up. That seems extreme. I don't know what, it just feels really insanely big.
I'm watching Candace live.
Oh, are you?
Wow.
All right. So I have a 1000 microfarad capacitor going to ground, and I have an 820 capacitor connecting pins 7 to 8. And you put those other ones away, right? Check my work.
Yeah.
Okay. It's fair to say that you probably do not want to touch these wires when you're dealing with this, because I have a feeling this could really store up some current. Okay, you got your timer ready?
Ready, set, go.
Let's see what happens.
I'm just gonna sit here for 15 minutes.
Pretty much.
I'm off 21.
It still took 21 seconds. That's it.
But when you press the switch, it will be pulled to ground.
Pulled to ground.
Pin 3 is our output to this LED, which it has a 150 ohm resistor. Pin 4 is our reset and is not used in this case. Pin 5, our control voltage, goes over to this little 1 microfarad ceramic cap and is then pulled to ground. Pin 6 goes to our timing capacitor, which then goes to ground. This is 22 microfarad.
All right.
Pin 6 is also tied to pin 7 via this jumper.
Timing capacitor to ground.
Yep, I got it. That's right. Ready? Okay, we're going to try again. Now that we have the capacitors hooked up right.
Just a second. Ready, set,
Yep.
go.
So just to verify, that is the 22.
Yes.
So basically what happens is the capacitor gets charged, okay? And it gets filled up, all right? And then the resistor, the size of the resistor, the more resistance means the slower that current can lead the capacitor.
That makes sense.
I may not be using the exact right words, but basically, so what you're doing is you're filling up this capacitor with all this electricity, and then you're telling it, the resistor, to only let it out really, really slow. So by having a big capacitor, it has a big store, and having a big resistor, it takes a long time for that store to empty. So the light won't go off until the store is empty. So that's how you're changing the delay. If you go a little resistor, the capacitor will empty much quicker, you know, because there's less resistance. And so you have a big capacitor with a little, so that's why you just use a small capacitor with small resistors if you want it to be a quicker switch. But that's basically what we're doing here is as soon as I hit the button, the capacitor filled up, and then it is slowly draining with with the resistor, it's slowly like pinching that garden hose off.
Yeah.